All right. Lucy stands on the edge of a vertical cliff and throws a stone upward. So the trajectory of this thing is, of course, going to be it's going to go up to some maximum height and then down and strike the water. This displacement here is down 80 meters, right? This is 80 meters here. So the first part says the maximum height reached by the stone is measured from the point where it's thrown. So they want to know basically what is this displacement here. Okay, so you're going to suvat that, right? Right, the final velocity at the top is a particular thing, right? You'll know that. You'll know the initial upward velocity, right? And you'll know the acceleration. They're telling you to use 10 meters per second, so you're going to use negative 10 for this. I don't know what would happen if you used 9.81. But anyway, go ahead and solve. You're solving for this, right? Then it says, determine the time for the stone to reach the surface of the sea after leaving Lucy's hand. So what I would do is I'd actually suvat from here to here, right? So S, U, V, A, and T, right? The acceleration is negative 10 meters per second squared, right? The initial velocity is this guy, right? The final velocity is we don't care. The displacement is, make it negative 80, right? Okay? So now you know this, you know this, you know this, right? Solve for the final velocity. Well, okay, you could do lots of two ways to do this, right? One way is just buck up, right? Ut plus 1/2 at squared, right? And this, what's funny is when you look at the mark scheme, they say to solve it by figuring the time to the top and then from there down to the bottom. That's working way too hard. Okay, so method number one, just plug it into here, use no final velocity, solve for t. It will be quadratic, and you will want the second root. Okay, is that right? Yeah, you'll have a negative root and a positive root. So use the only positive root. That's got to be the right answer. Okay, I don't feel like using the quadratic equation, but you might. The other way to do it is to use v squared is u squared plus 2as. Solve for this guy. Don't forget that when it strikes the water, it's going down, right? So you're going to have to do something with that velocity to get it right. You'll have to make it negative, right? And then just use v as u plus at to find the time. Make sure you show all your work in that little box.